All right, so moving on to empirical formulas today. Empirical formula is basically the simplest whole number ratio of elements. When you simplify a molecular formula, the simplified version is known as the empirical formula. Simplified whole number ratio of elements. Molecular formula is the total number of elements. Okay. For example, let's say if I write C2H4. Now C2H4 means that there are 2 carbons in a compound and 4 hydrogens. This is a molecular formula. This is the total number of elements in a compound, right? When you simplify this, 2 ones are 2, 2 twos are 4. Now this simplified version is CH2. This CH2 is the empirical formula. This is the molecular formula, and the second one is the empirical formula. Okay. Similarly, let's write some more examples here. What if, let's say, you have N2H4? N2H4 is again the. So how do you know that N2H4 is a molecular formula? Because it still has further capacity to get simplified. 2 and 4, you can simplify it. 2 ones are 2, 2 twos are 4. By dividing these numbers, these subscripts, with the lowest number possible. Okay. So once you divide these numbers, simplest forms. Okay, and those simplest forms are the empirical formulas, and this is how you know that the formula given to you is whether it is a molecular formula or is it an empirical formula. You look at the subscripts. If there is further capacity for the number to get simplified, then it is a molecular formula. Again, for example, C8H18. Now this, you can start simplifying this with the table of 2. 2 fours are 8, 2 nines are 18. And it can 4 and 9 be further simplified? No, because 4 and 9 cannot be simplified on one table. So the empirical formula for C8H18 is C4H9. Now we cannot simplify C4H9 further with the same number. Let's say if you're given with NH3, NH3 cannot be simplified further because there is a 1 here and there's 3, and you cannot just simplify it further. So NH3 is the molecular formula as well as the empirical formula. Are you clear? Should we move on?
Yes.
Okay. Now there are multiple ways to figure out the empirical formulas as well. Let's say if for example, moles are given to you and you are not given with any of these subscripts, then you can use moles to figure out empirical formulas as well. Okay, we're studying this case 1 here. Let's say if you have MgO given, magnesium oxide, and if I tell you that moles of magnesium, moles of magnesium are 0.02 and moles of oxygen are 0.02 as well. So in this case, if you're given with the moles of these separate elements, what you're going to do is you'll divide these moles. You're going to write these ratios: magnesium, oxygen, 0.02, ratio 0.02. Simplest, both of these are the simplest numbers, right? So you're going to divide them. You can pick up any number and divide. So the answer will be 1 ratio 1. So if answer is 1 ratio 1, then MgO is itself the empirical formula. Is it clear up till now?
Yes.
Okay. For example, now the ratio is not 1, 1. This is case number 2. When the ratios are not the simplest, in that scenario, for example, if let's say the compound is PO, potassium oxide, and you are given with the moles of potassium, Moles of P are, let's say, 0.05, and moles of oxygen are 0.125. So now you can again write P ratio O. P is 0.05. Oxygen is 0.125. You're going to pick up the smallest one, 0.125, and divide it with both on both sides. 0.125, you're going to get 1 here. And if you divide it on this side, you'll be getting, if you divide it, so you'll see you'll get a 2.5 here. Answer will be 2.5 here. So if this is the answer, 2.5 ratio 1, what you can do is, I mean, because obviously your empirical formula cannot be in decimals, right? So you need to multiply this entire thing with the simplest whole number to convert it into whole numbers. So for example, if you multiply this entire thing with 2, so 2 ones are 2 and 2.5s are 5. So 5 ratio 2 is the answer. This P5 is with P and 2 is with oxygen. So your empirical formula will be P5O2.
Why did we multiply it with 2 and not another
Because,
number?
sorry, why did we multiply with 2 and not what?
Another number, why 2?
Because 2 is the simplest, smallest number that could give us a whole number. You could have used 3 as well. I mean, if you use 3, you're going to get another number that could have been further simplified over here. So you need to pick a number that is itself the smallest one, and it gives you the most straightforward ratio here. So you cannot use 1 because 1 will obviously give you again a decimal number. So 2 is the most appropriate number. Again, we are supposed to pick the smallest number. If you, let's say, decide to multiply it with 3, can you tell me what is 3 times 2.5?
7.5.
Again, you're getting an answer in decimals. 3 is not the appropriate number. Okay, this is why we're using 2. 2 is the smallest possible number that gives us a whole number. And even if you go for 4, so again, you'll have to attempt further simplification at this step. So 2 is the only number that's going to give you the simplest and smallest number, the simplified ratio set. So this is how you can calculate empirical formulas when you're given with moles. This was another technique. All right, now there's another way to calculate empirical formulas. Let's just write the names of these cases as well. So the first technique, this here was calculation of empirical formula through simplification. You can write it here, so it's going to be easier for you to understand these questions later on. Calculation of empirical formula through simplification. Number 2, these further 2 cases were the calculation of empirical formula through moles. And number 3 is what we're going to do right now. Let's just write the name as well. It's calculation of empirical formula through percentages. All right, so for example, you're asked to find empirical formula of there's a compound having CNH. A compound having carbon and hydrogen. So in that scenario, let's say you're given a percentages. Hydrogen is 85.7%. And carbon is 14.3%. C ratio H. And you're asked to find the empirical formula. So now what you're going to do is, for the first step will be to write the names of these elements, then write the percentages underneath. 85.7 under carbon and 14.3 under hydrogen. Next step is to write down the MRs, the molecular masses. 12 is for carbon and 1 is for hydrogen. Once you've written these, you're going to
The
divide them.
percentage carbon की percentage 14.3 नहीं थी?
Yes, it is 14.3. Oh, sorry. Oh, yeah.
तो फिर नीचे
Yeah, yeah. Sorry.
8.55.
Change हो जाएगा. Carbon was 14.3 and hydrogen was 85.7. Yeah. Up, you've written 12 underneath 14.3 and 1 underneath 85.7. Now what you're going to do is you'll simply divide 14.3 divided by 12, 85.7 divided by 1. So I think, wait, I think I've made a mistake here. The mistake is that carbon should be more.
Lowest quantity से नहीं divide करते.
नहीं, इसमें नहीं करते. जब परसेंटेजेस आए तो आप वो सब हम मोल्स में कर सकते हो. हम इसमें नहीं कर सकते. अच्छा, हम ये करेंगे कि हम यहाँ पे ना इनके परसेंटेज चेंज कर देते हैं, क्योंकि आई थिंक दिस इज नॉट पॉसिबल. टेक्निकली बहुत छोटा आंसर आ जाएगा. तो कार्बन मस्ट बी 14.3 एंड हाइड्रोजन, या ऑब्वियसली देखो ना, एक ऑर्गेनिक कंपाउंड में यू ऑलवेज हैव मोर हाइड्रोजन देन कार्बन्स. सो 85.7 ही होगा यहाँ पे. एंड दिस इज हाउ ये सारा रिवर्स होगा. इसके नीचे नहीं, मैंने ये चीज कैसे लिख दी है. सॉरी. Yeah, 85.7 carbon and hydrogen is 14.3. 85.7 and 14.3. Okay, now up say it. What you're going to do here is you divide the percentage with the MRs. This is the step. Percentage over the MR. So percentage of carbon is 85.7 and MR is 12. Hydrogen is 14.3, MR is 1. So can you use a calculator and tell me what's the answer for 85.7 over 12?
$85.7 divided by 12 is 7.14.
And 14.1 by 3 is 14.3 by 1 is 14.3. Now, since you have these two numbers after division, your next step will be to pick up the smallest number and divide it on both sides. 7.14 and 7.14. You're going to get a 1 here. And what is 14.3 over 7.14? It's 2, I think.
Hello?
Yeah, is it 2?
I can't hear you.
Can you hear me now?
Yes.
Okay, so 14.3 over 7.14 is 2. You've got these two numbers for the empirical formula. C, this is for carbon and this is for hydrogen. So your empirical formula is CH2. Got it? All right. This was all for calculating the empirical formulas. Now we're going to study how to calculate molecular formulas with the help of empirical formulas. The reverse order now. Okay, so for molecular formulas from empirical formulas, it is important that you have the relative formula mass of a compound and the empirical formula mass. This is very important. So the data that you need to know is the MR of compound, empirical formula mass, and obviously the empirical formula as well. Or, I mean, yeah, you should just know the empirical formula. You can further calculate the mass from that formula. So these two things are very important. So let's suppose an example question of a sort that you are given with CH2Br as the empirical formula. So the empirical formula is CH2Br. And the question tells you that the MR of the molecular formula, I mean the molecular formula that you're supposed to find here, that molecular formula will have an MR of 187.8. Tell the molecular formula. This is the question. So your first step will be to divide both of these masses. MR divided by empirical formula mass. So how are you going to get the empirical formula mass? You look at the compound CH2Br. So CH2Br, carbon is 12, hydrogen is 2, bromine is 79. Could you please check? Is bromine 79 or 80?
79.9.
Okay. So this is now just add these all 79.9 plus 2 plus 12.
Your voice isn't clear.
Sorry, I was saying you can add these all now 79.9 plus 2 plus 12. Can you hear me?
Yes, now I can. I'm supposed to add these?
Yes, yes, please do.
It's 0.09 into 10 power 3.
How? You're adding these. Though you need to. Are you telling me the answer to after the division?
No, I added these value 12 plus 2 plus 79.9.
And what is the answer?
Let me add again.
Yeah, please. Shouldn't be 93. 93.9. Is it?
Yes, 93.9.
Okay, perfect. Now you have the empirical formula mass as well. What you're going to do is you'll divide both of these. Molecular formula mass is 187.8 and empirical formula mass is 93.9. Once you do the division, can you do that as well? Divide these both.
Two.
2. So this 2 is known as the value of n now for the calculation of empirical formula. This is very important. This is n. Why? Because the molecular formula is equal to n times the empirical formula.
Sorry, your voice got cut
Yeah,
in between.
molecular.
I didn't understand.
Okay, I'm saying that molecular formula is equal to n times the empirical formula. Okay. Let's say if the molecular formula, we were supposed to find the molecular formula, the empirical formula was CH2Br. You're gonna multiply this with 2. This 2 is gonna add up to chlorine, to hydrogen, to bromine separately, and your molecular formula will be C2H4Br2. Is this clear?
Your voice isn't clear. I
Oh,
didn't catch anything.
sorry, just give me a second. Something like this. Okay, can you hear me now clearly?
Yes.
Okay, so I was saying this answer that you got was for n. Molecular formula is n times the empirical formula. Okay. If let's say the empirical formula was CH2Br, so you're going to multiply 2 with this entire formula. 2 will get added onto this carbon, this hydrogen, this bromine separately, and your molecular formula will be C2H4Br2. All right.